Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily lead code problem, and the problem's name is single number part 3. So you will be given an array of integers where exactly there will be two elements that will appear only once, and rest all other elements will appear exactly twice. So find the two you have to find the two elements that appear exactly once. You can return the answer in any order. Okay. So you must write an algorithm that runs in a linear time complexity and uses constant extra space. Okay. So basically you have to return an array. So this array that you will be using of size 2 will not be counted in the extra space. Other than that, you should be using constant extra space. Before thinking of an approach to solve this particular one, let's have a quick look at the constraints. So according to the constraints, the length of the nums array will be of order 10 raised to power 4, 3 into 10 raised to power 4, and each integer here, each entry in the nums array will be ranging from minus 2 raised to power 31 to 2 raised to power 31 minus 1. Okay, so each integer in nums array will appear exactly twice. Only there will be two integers that will be appearing once. Okay, so these are the constraints. So let's quickly think of a approach which will be using linear time complexity and constant extra space. Okay, so let's open the board. Yeah. So first of all, there should be you should be knowing a property. Basically, what from the approach that I can think of, it leverages bit manipulation property of XOR. You can say when you XOR a number with itself, it results into 0. So this is the property. So A XOR A is 0. So we can leverage this property to solve that problem. How? Let's say the given array is A, B, C, D, D, E, E, G, and G. Okay. So all these numbers are appearing twice. Okay, and only these P and C are appearing once. Okay, so let's say you initialize a variable, let's say total XOR. Okay, and it's initially set to 0. When you XOR a number with 0, 0 XOR something, let's say A is the number itself. So that's why we are initializing it with 0, and then with we will be traversing this array in this direction, or you can traverse from right to left also. That's totally dependent upon your choice, but let's say we are picking this, you know, we are choosing from left to right direction. And when you will be visiting each number in this array, then you will be XORing it with the total XOR. So all of the double entries will be cancelling each other out because of this property, A XOR A equal to 0. Okay, so D will cancel itself, E will cancel itself, G will cancel itself. Only these two will be remaining. Let's pick another color. Okay, these two will be remaining. But when you will be getting this total XOR, these two will be intertwined with each other because of this XOR operation. So total XOR will be having this value. Okay, rest everything will be gone because they will be cancelling each their first appearance will cancel the second appearance of each character or each number, you can say, integer. Okay, so you will be having this, but it is difficult to separate these two out. Okay, because it will be represented by some integer, let's say 5. So we cannot know that what two integers formed 5. Okay, for that we have to devise some trick in order to separate them out. Okay, so since what you can do is you can find there is a another property of XOR that you can leverage to solve this particular sub problem that is arising of separating these two out. uh, 1 XOR 0 is equal to 0, and so and 0 XOR 1. Okay, whenever the bits are different, then only the bit is 1. Whenever the bits are same, 0 0 1 1, both of them will result into 0. Okay, so we need to find the first different bit. Okay, in these two, or if even if any bit position will work out, basically you have to find the bit position which is different in these two. Okay, so B and C, there should be some binary representation of B and C. Okay, let's say this is for B and this is for C. Okay, so there will be some difference here, so we need to find any bit position which is having bit difference. Okay, and how we will know that bits in that particular bit position is different in both B and C? Their XOR will have value 1 for that bit position. Okay, so if you XOR these values, so 0 0 it will be 0, then these bit are different, so it will be 1. These are also different, it will be 1. Let's say this is 1, then these two are same, so it will be 0. So these two are also same, 0. These two are different, 1. You can take either of these two. Okay, that really does not matter, but I have picked the least significant bit, the very first bit from the left hand side, right hand side, that is set. Okay, so from this direction I have picked the very first bit that is set in their XOR. Okay, so this is the very first bit in their XOR which is set. So this was B, and this was B XOR C. Okay, so I will turn off every other bit and keep this bit on only. So it will look something like this: 1 0 0 0 and 0. Okay, so I am having the least significant bit set, or the difference bit that will be there. Okay, so it is very well understood that one of uh, one of the numbers from B and C will have this bit as the set bit, and another will have this bit as the unset bit. Okay, one of them will be having this bit as set, and none of them other of them will be having this bit as unset or off. Okay, that's why it resulted into 1, because these two are different at that time. So it will help us to separate them out. How we will be doing that? For all the integers whose this particular bit position is set, we will group them in one group. Let's call them first group. Okay, and all those integers whose this particular bit position is unset, we will group them into the second group. Okay, so since Other than these two integers b and c, everybody is appearing twice. So for grouping, which operation should we use so that everything else cancels itself out? So we will be using XOR operation. Okay, so we will be having two variables, first group and second group, both initialized to 0. Whenever we encounter a number, then we will do one more traversal of this array to separate this b XOR c out. Then we will be doing that traversal from left to right or right to left. It is totally up to you. We are choosing left to right. Then whenever we see a number that is whose bit is, first bit, this bit position, particular bit position is set, we will give it to the first group. Okay, and keep XORing its value with the first group. Because of this XOR operation, only that number will be left which is appearing once in the first group, and similarly c will appear in the second group. Okay, it can be other way around, c can appear in the first group and b can appear in the second group, but these two number will be separated for sure. So what tricks did we use? First trick or the fact that we used was XOR operation. XOR a is 0, and the second one that we used was this one, 0 XOR a is equal to a. The third trick that we used is whenever uh in a particular bit position between two numbers there is a difference, either one of them is set and another one is unset, then only for that bit position we will set the bit in their XOR. Okay, so this was the third observation or the third fact that we used of bit manipulation, and it helped us to separate these two numbers out. Okay, and there was another, you can say the problem statement was designed in such way that by applying XOR operation you can cancel everything out, just b and c will be remaining, and uh, we just, for before doing that we found out what is the least significant bit that is set. Okay, from right hand side we found out the first bit that is set in their XOR value. Okay, so let's have a quick look at the implementation. Things will be more clear in the implementation if you are still not sure about how things are going on. So let's take it to the board. Okay, this is the implementation. So we will have a variable. This is, you can say, total XOR. I have represented it by a XOR b in terms that, these two numbers will be only remaining after we are done with, XORing every number with this variable in the nums array from left to right direction. Okay, so a XOR b only will be remaining. So we have to now separate out a XOR b, a and b. For that we will be using another observation, least significant different bit. Okay, so you might ask that how this is gonna work. So let's say a XOR b binary representation is something like 0 1 1 1 0 0 0. Okay, so let's say you subtract 1 from it. Okay, so it will be something like 1 1 0, then 1 1 0. Okay, so this is a XOR b minus 1. Okay, then when you will negate this entire thing, a XOR b minus 1, you have to just change 0 into 1 and 1 into 0. Okay, so this number will become 1 0 0 1 0 0 0. Okay, when you will do a AND operation on these two binary representations, what you will get? Let me write it down for convenience. 1 0 1 1 1 and then rest all are zeros. Okay, when you will do a AND operation on these two, this was A XOR B, you will see that all the bits will be turned off except the least significant bit. Okay, so this bit is only remaining. This was the least significant bit, the bit that was set from the first bit, that was from right hand side, that was set, you can say. Okay, so you will be having this bit as set because of this operation. Okay, and then you will be checking, you will be forming two groups. You will, if the least significant bit is set in a particular number, then you will give it to the first number group. Okay, this group. And if it is other way around, that this bit is not set, this bit we are talking about in a particular number, then you will give it to the second number. Then since order was not a concern for this problem, so you will just return the first number and second number, array having first number and second number only. Okay, so this is how you will be solving it. And as per the requirements of the problem statement, time complexity wise, this will be order of n, where n is the size of the nums array. It is linear time complexity. And space complexity wise, as you must have seen that except this integer array that we will be returning as a return type, we are not using any extra space, so it's constant. Okay, so these are the complexities. This is the approach and implementation. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching, and I hope this solution walkthrough added some value to your DSA journey of honing your DSA skills. And till then, keep solving problems and keep practicing.